So now we're going to look at this equation 2 sine of 3 theta minus 1 equal to 0. And this one takes us in a different direction since we're looking at 3 theta inside of the sine. The first thing I'm going to do though is similar to what we've done before. We're going to add over the 1. We're going to try to get the sine by itself. So the 1 will go to the other side. We'll divide both sides by 2 so that we can have this as sine 3 theta equals 1 over 2. And so what I'll do now is I'll take the sine inverse of both sides. Okie doke. Now all that does is it solves for 3 theta. And when we do the sine inverse, we're going to talk about two different solutions here. 3 theta can equal to pi over 6 or 5 pi over 6. So from that 1/2, we actually get these two different locations for 1/2. But that's for 3 theta. And now generally we do all solutions by adding a plus 2 pi n to each of those. But this doesn't quite solve for all solutions. We still got to take care of the 3 in front of theta. The way we do that is we multiply everything by 1/3. Technically it's the same thing as dividing by 3, but it's just more convenient to do it this way. So if I do that, this will cancel out. This 1/3 is going to multiply to everything, the pi over 6 and the 2 pi n, on both of our solutions. So what we're going to get is theta equals pi over 18 plus 2 pi n over 3, or 5 pi over 18 plus 2 pi n over 3. So this altogether represents all solutions. However, we're going to talk about the solutions between 0 and 2 pi. So here's how it's going to work. We're going to start at pi over 18 and 5 pi over 18. We're going to add to each of those 2 pi over 3, and we're going to stop at 2 pi. So let's think of this. If we add 2 pi over 3, we need a denominator of 18. So that would be 12 pi over 18. And if we stop at 2 pi, that would be the same thing as 36 pi over 18. So we're going to start with pi over 18. Then we'll add another 5 pi or 12 pi over 18. That's going to equal to 13 pi over 18. So there's one solution and there's another solution. We'll keep adding the 12 pi over 18. The next one would be 25 pi over 18. And then we get 37 pi over 18. But that's going past 2 pi. So that's where we stop. We don't go past that. So that wouldn't be in our solution between 0 and 2 pi. Only pi over 18, 13 pi over 18, and 25 pi over 18 would. Now if we start from the other number, 5 pi over 18, and we take 5 pi over 18 and we add 12 pi over 18, we get 17 pi over 18. So we have one solution, another solution. If we add it again, we get 29 pi over 18. That still is less than 2 pi. But if we add it another time, we get up to 41 pi over 18. So now that's going all the way past 2 pi. We've gone too far. So the solutions between 0 and 2 pi amount to pi over 18, 13 pi over 18, 25 pi over 18, 5 pi over 18, 17 pi over 18, and 29 pi over 18. So we have 6 solutions for this equation between 0 and 2 pi. So here we're going to start with secant 3 theta over 2 equals to the square root of 2. My first strategy is to take the secant and write it as 1 over cosine again. But that's still 3 theta over 2 for the cosine. And that's going to be equal to the square root of 2. Now to continue to solve for here, I'm going to reciprocate each side of the equation. So if I take the reciprocal over here, it'd flip it around to just cosine 3 theta over 2. But taking the reciprocal of the other sign would turn it into 1 over the square root of 2. And rationalized, that would be the same thing as square root of 2 over 2. So now that gives us a more appropriate way to try to solve this. We're going to take the cosine inverse of both sides, and so that would solve for the 3 pi over 2. We'll get two answers. One is pi over 4, and 3 pi over 2 is equal to 7 pi over 4. For all solutions, we would add the plus 2 pi in on both of those. But once we've done that, we're still left trying to solve for theta. So what I'm going to do here is multiply both sides by 2 over 3 on both of our answers that we have here. By multiplying by 2 over 3, I'm canceling out the fraction here. Okay, and this 2 pi over 3 will distribute to both of these. So we're going to get theta is equal to pi over 6 plus 4 pi n over 3, and theta is equal to 7 pi over 6 plus 4 pi n over 3. This is going to represent all solutions to this equation. And now we're going to break it down though and find the solutions between 0 and 2 pi. Okie doke, and so what we're going to do is we're going to start at the pi over 6 and the 7 pi over 6. To that we're going to add the 4 pi over 3 with a common denominator that would look like 8 pi over 6. And we're going to stop at 2 pi with a common denominator that would look like 12 pi over 6. So we're not going to go beyond that to list out the solutions. Okay, so starting with pi over 6, we're going to start there. That's our first solution. And to that, we're going to add 8 pi over 6. That's going to equal to 9 pi over 6, or simply 3 pi over 2. Okay? Now if we add again an 8 pi over 6, it would be 17 pi over 6. But we notice that's going beyond 2 pi, so that's where we're going to stop. If we start with 7 pi over 6 and add, that's our first one, and then we try to add to 7 pi over 6 the 8 pi over 6, we'll immediately go to 15 pi over 6. And that's going beyond the one rotation of 2 pi, so we only have 3 solutions between 0 and 2 pi. Pi over 6, 3 pi over 2, and 7 pi over 6. Okay, and now we're going to look at square root 3 tangent theta over 2 minus 1 is equal to 0. Okay, the first thing we're going to do here is to isolate the tangent, so we're going to start by adding 1 over. And then we're going to divide both sides by the square root 3. So we're going to get tangent theta over 2 equals 1 over the square root of 3. But we do recognize that that would be rationalized as square root 3 over 3. So let's go ahead and take the tangent inverse here of both sides to solve for the theta over 2. So theta over 2 is tan inverse of square root 3 over 3. Now for tangent, there's only one location where that happens in one rotation, and that is at pi over 6. And so that would be, when we do all solutions, instead of 2 pi n, it would just be plus pi n, since this is tangent. So that only, though, solves for the theta over 2. To solve for theta, we're going to multiply both sides by 2. We got to distribute this there, and we're going to get theta is equal to pi over 3 plus 2 pi n. And so that's going to represent all solutions to this equation. Now if we want to look at the solutions between 0 and 2 pi, well, we start with pi over 3, but if we tried to do pi over 3 plus 2 pi, that would automatically go beyond 2 pi, because that would be equal to 7 pi over 3, which goes beyond that. So we're not going to actually add any 2 pi's here or anything to it to get any more solutions. The only solution between 0 and 2 pi is just pi over 3.